Okay, this lesson is for Mrs. Cucci's College Now Pre-Calculus class. Today we're going to be talking about polynomial division, the remainder theorem, and the factor theorem. Okay, so by the end of this lesson, you should be able to perform long division, should say long, I apologize, long division with polynomials and determine whether one polynomial is a factor of another. You should be able to use synthetic division to divide a polynomial by x minus c, some binomial x minus c. Use the remainder theorem to find a function value f of c, and use the factor theorem to determine whether x minus c is a factor of f of x. Okay, so division and factors. When we divide one polynomial by another, we obtain a quotient and a remainder. If the remainder is 0, then the divisor is a factor of the dividend. So again, if we divide and we get a remainder of 0, that means that divisor is indeed a factor of the dividend. The dividend is your original, okay? Okay, so we are going to divide to determine whether x plus 1 and x minus 3 are factors of x cubed plus 2x minus 5x minus 6. Okay, so we're going to try the first one. We're going to start with x plus 1. And we're going to do long division here, and we're going to use our polynomial x cubed plus 2x squared minus 5x minus 6. This is what we call the dividend, okay? Okay, this right here is our dividend. All right, this is our divisor. And whatever goes up here is going to be our quotient. Okay, so let's give this a shot. All right, so what we need to start by doing is figuring out how this goes in. So what we're going to do is we're going to use this value of x, okay? And we're going to see how this goes into my dividend, this piece here, all right? So here's the rule. You're going to think about this value of x. What do you need to multiply x by to get x cubed? That's what you're going to put above it, okay? So x times x squared would give us x cubed. So let me get rid of this so I have some room here. Okay. So then what you're going to do is you're going to take that x squared and you're going to distribute it back, okay? X times x squared is x cubed, and we're going to put it underneath. And then x squared times 1 is x squared. So this is how we get the next piece. So what we're going to do from here is we're going to subtract that. Remember, when you're subtracting polynomials, you got to distribute that through, all right? So x cubed minus x cubed, those first terms should always cancel. And then 2x squared minus x squared gives us 1x squared. And we drop the next term, minus 5x. So then we follow that procedure again. What would I have to multiply x by, this x here, to get x squared? Okay, x times x, so plus x, is going to give us that x squared. Take that x, distribute it back through, minus x squared plus x. And again, those first two terms will cancel. And then negative 5x minus x, because we're distributing that through, minus 6x, drop the minus 6. Okay, same process. How do I get x to be negative 6x? And that's by multiplying by negative 6. Distribute it back through. 6x minus 6. Subtract gives me 0 and 0. Okay. So here's my remainder. Okay, so my quotient is x squared plus x minus 6. Since the remainder is 0, that tells us that x plus 1 is a factor. Okay, it tells us that x plus 1 is a factor. It also tells us that the quotient and the factor, if I were to multiply them together, it would give me back my original. Okay, so let's try it with x minus 3. Okay, let's try it with x minus 3. Let's change the color so I know I'm in part 2 here. Okay, so x minus 3 divided into x cubed plus 2x squared minus 5x minus 6. All right, so again, how am I going to get x to be x cubed? We're going to multiply it by x squared, distribute it back through x cubed minus 3x squared, and subtract. Those cancel, and we get negative x squared. Drop the 5x. X times what is negative x squared? That would be a minus x. Distribute it back through. And subtract. So again, we got to change those signs, right? So those cancel, and this becomes negative 8x. Drop the 6. Okay. Now the next piece, x and negative 8 gives us negative 8. Distribute back through. Negative 8x plus 24. Subtract gives us negative 30. Here's my remainder. Okay. Since my remainder is not 0, x minus 3 is not a factor of x cubed plus 2x squared minus 5x minus 6. Okay? So since it's not, then it's not a factor and we're good to go. All right, so that's how we determine using long division whether or not something is a factor. Okay, so long division isn't that difficult, just takes a little time and a little practice. Okay. So, let's talk about the remainder theorem. Oop, too many A's. Remainder theorem and synthetic division. So let's consider the function h of x equals x cubed plus 2x squared minus 5x minus 6. When we divide h of x by x plus 1 and x minus 3, the remainders were 0 and I got 30. This is a little off. 0 and 30, respectively. Let's now find the function values for h of negative 1 and h of 3. So again, this is an important note. The function values were the same, should be the same as the remainders, and this should suggest the following theorem. So when we go to find h of negative 1, we're going to store x as negative 1. Okay, we're going to put in our function. And we get negative 4. Did I type in something wrong? I did. I missed a square, didn't I? Let's change that. Okay, so we get 0. Okay, so that matches with our remainder, so we're good. So x store 3. I'm going to go up and borrow this so I don't have to type it out again. And we get 24. I must have done something wrong in my long division. I'll have to go back and check that. Okay, so again, the remainder should match the function value. Okay, so let's see what we did wrong here. All right, x squared, x cubed, distribute it back through, negative 3x squared. We're good there. Okay, Here's my problem. This I should have made a positive when I distributed through. This should have been a positive 5x. Okay, so let's fix. Sorry about that, guys. It's a good catch. Okay, so when I distributed that through, I have to distribute through that negative. Those cross out and I get 5x squared. Drop that negative 5x. X to get 5x squared is going to be it's going to be plus 5x. Distribute that back through. 5x squared minus 15x. Distribute through that negative. And we get 5x. Drop the 6. X to get 5x would be plus 5 plus, this is 10. Okay. We get 15 minus 5 is 10. X to make 10x would be plus 10. Distribute that through, and we get 10x minus 30 minus plus, and we get 24. There it is. Okay, since the remainder is not 0, it doesn't work for us. Okay, so again, remainder theorem says that if I find that function value and it equals the same as your remainder, then we're okay, we're spot on. Okay? All right. So the remainder theorem, if a number c is substituted for x in the polynomial f of x, then the result f of c is the remainder that would be obtained by dividing f of x by x minus c. Okay? So again, you're going to get that remainder by substituting in the value. Okay? Then that's a very quick, easy way to determine whether or not something is a function of your original polynomial. Instead of having to divide it out, is it a factor? Use the remainder theorem, plug it in, and see what you get for your function value. Okay, so the remainder theorem motivates us to find a faster way of dividing by x minus c in order to find function values. So mathematicians have developed something called synthetic division. This process uses the coefficients of each term and the integer value of the divisor. So let's give it a shot. This is actually a lot of fun. So hold on just a second here. Let's try this one. Okay, so the original function that we wanted to try was 4x cubed minus 3x plus x plus 7 divided by x minus 2. Now, in order to use synthetic division, it does have to be in this form, this x minus c. Okay, so that's important. You can't use it if it's not. I need to fix this because it's bothering me. Okay, so here's how we set it up. What you're going to do is we're going to take the c value, which in this case is 2, and we're going to put it in a little box. Okay? Next thing we're going to do is we're going to take our coefficients in descending order. So we've got a 4, and we have to make sure that they're all included. So I should have if I have an x cubed, I should have an x squared, which I do. I just erased it. X squared, an x, and a constant. So we're going to take those coefficients, 4, negative 3, 1, and 7. And notice I left a little space. Okay, that's important. So your first step is to drop the 4. Okay, you're going to drop that 4 and just bring it down. All right. Your next step is to take this 4 and multiply it by your c value. 2 times 4 is 8, and you're going to put it underneath the negative 3. Then you're going to add. Negative 3 plus 8 is 5. So then you do 2 times 5 is 10. You put it under the 1, and you add 11. 2 times 11 is 22, and you add 29. Okay? So basically what this says for us is that this function divided by this function is going to be this. All right. Now, what I mean by this is we can piece it back together. This number here always represents the remainder. Okay, so this is another way of determining whether or not something is a function or a factor. Because this isn't 0, x minus 2 is not a factor. Okay, so that's another way of determining it. Now, the actual division piece, it tells us that when we divide it, the quotient would be 4x squared plus 5x plus 11 with a remainder, and that's not how we write it. When we do our remainders, we do plus 29 over x minus 2. Okay, so the remainder over the divisor. Okay, so that's how we piece this together. So again, it's much faster to use synthetic division. All right, so let's try another one. Let's try 2x cubed plus 7x squared minus 5 divided by x plus 3. Okay. So the first thing you need to notice is when we're dealing with this, we said that we always want to use x minus c, right? So this doesn't look quite right. So really what this is x minus a negative 3. So we know that our c value is actually a negative 3. Okay, so that's what's going to go in our box, my negative 3. We use our constants, or our coefficients. We've got our 2, 7. And then remember, we have to have one of everything. We've got 3, we've got 2, we need 1. And since there's nothing there, we have to put in a 0 in its place. And then a negative 5. Okay, drop that 2. 3 times 2 is negative 6. Add gives us 1. Negative 3 times 1 gives us negative 3. Add gives us negative 3. Negative 3 times negative 3 gives us 9. Add gives us negative 4. Okay, so the quotient is going to be 2x squared plus x minus 3 with a remainder of 4, or negative 4. So we're going to have negative 4 over x plus 3. Okay, so there is something else we can do with this, and that is that we can use this to find function values. Okay, so if I wanted to find function values, if I wanted to find f of 10, instead of using the remainder theorem, what I can do is I can use synthetic division, and f of 10 winds up being my remainder. Okay, so we've got 2x to the 5th minus 3x to the 4th plus x cubed minus 2x squared plus x minus 8, and I want to find f of 10. Okay, so we set up my synthetic division. We're going to use 10 as my divisor. Our coefficients. Okay, drop my first term, multiply and add, multiply and add, multiply and add, multiply and add, multiply, and some of these do get really big, and add. Okay, so f of 10 equals 170,802. Okay. So could you use it? Could you find it just by plugging in? Yeah, you could. Either way works, but if I ask for one and you give me the other, I'm going to mark it wrong. And it is going to give you the same value. Okay? So you do have to know how to do it both ways. Okay, we're going to stop here, and then we will come back with another example of this. All right. See you guys tomorrow. Come and prepare a question.